Okay, so today we're going to learn about piecewise functions. What piecewise functions are? It's two or more functions So look at this example. This is one function. This is the other function. So it's two or more functions, each with their own domain. So you can't just plug in anything. It's restricted. So for this top function, it says you can only plug in x values that are less than -2. Can I plug in a 10? No. It's telling you what you're allowed to plug in. For this bottom one, it says you can only plug in x values that are greater than or equal to -2. So this is an example of a piecewise function. We have two or more functions, and they each have their own domain. They have their own restrictions and requirements. So let's look at letter A. A wants the function for when x is -5. So if x is -5, according to my domain, which one can I use? F of x equals x squared minus 1 is one function. F of x equals 5x plus 3 is the other one. So we have two different functions. Now, I'm looking at this question. I'm using -5. X is -5. Does this make sense? Is -5 less than -2? Okay, that's good. Is -5 greater than or equal to -2? Okay, so we're not going to use this bottom one. We're going to use this top one for -5. Okay, that's how you figure out which one you want to use. So if I plug in a -5 here, what's -5 squared? -1. So this one is 24. Let's do the same process again. We have to figure out which function are we going to use. This time, my x value is -2. So we have to figure out which equation we're going to use. -2. Is -2 less than -2? No. Is -2 greater than or equal to -2? Yes. So we're going to use this bottom one. So guys, we're going to plug in a -2. We'll get -10 plus 3. So this is -7. Now let's do the last one. We need to figure out which function we're going to use. They gave us the number 7. Since they gave us 7, which one will I use, the top or the bottom one? Yes, because 7 is greater than or equal to -2. It's not less than -2. So I have to use the bottom one. We're going to plug this in. 5 times 7 is 35, plus 3 is 38. So this one is 38.
I have a question.
Yes.
What if it was good for both of our functions?
Okay, we'll go over B. So the number they gave us is -1. Is -1 less than or equal to -4? No. Is it between -4 and 1? Is it bigger than +1? Okay, so the only one it works for is this one. So this is where we're going to plug it in. So I'm going to copy this down. It has negative and then the x value -1. We're going to plug in a -1. What do two negatives make?
Positive.
So 1 minus 1 equals 0. So this is 0. Okay, now we're going to practice graphing these piecewise functions. Okay, so guys, let's look. Let's look at the domain first. This is the number -3. Let's plug in a -3 here. I'm going to make a table. Everyone draw a table. So if I plug in a -3 for the x value, this is the equation. What do I get? -3. Okay, so let's plot that point. -3 is right here. And that will be a closed circle. Can someone tell me why this is gonna be a closed circle and not an open one? Exactly, because this has an equal to sign underneath. That's why it has to be closed. Okay, so guys, let's finish my line. This is a linear. What's the slope? It's just one. So I'm just gonna continue my line. This is the line, that's the slope. Question, why am I not continuing the line this way?
Negative.
Yes, it says x has to be less than -3. It has to be less than or equal to -3. This is -3 here. So I need to be on this side of -3, the left side of -3. So I'm not continuing the line on this side. Okay? All right, let's do the next one. They gave me a -3, so let's plug this into the equation. I'm going to do a different table. I'll just split it. I'm plugging in a -3 again. What is -2 times -3? Plus 1. We got 7. So guys, let's go ahead and plot a point at -3, 7. What kind of circle will it be? Why did you guys say open? Yes, it doesn't have a line underneath. So we're going to do an open circle. Okay, so guys, let's do my slope. What's my slope? So I'm going to go down 2 over 1. I need to create a line that is going down because it's a negative slope. So down 2 over 1.
Why is it all the way up there?
Because this is my point. No, the only one that's open is this one because you can't be on -3, but you can equal everything else. We just have an open circle at -3 because we're not including -3, but we can be bigger than -3. So this is our line. Yes.
If you were to put like a dot, make the point, that be off, because it looks like a closed circle.
Yes. Okay, so this is our line. And I know I did it correctly because look, my y-intercept is what? 1? And that's what the equation has, 1. And my slope is down 2 over 1. So that's good. We did it correctly. Okay, let's talk about the domain. Domain means what are all of the x values that are here? What x values are being represented? So it goes all the way to the left forever, right? So that will be -infinity. Is there a point -3? Because it kind of stops here. Yep, but it's represented. This is the point -3, -3. So x, the -3 is being represented. Is everything after -3 being represented? Yeah, and it goes off to infinity. This is all real numbers. This is -infinity to infinity. Now, let's talk about something else. Guys, look. Before you get lost. No, before you get lost. Let's pretend that this was an open circle. At -3, this is open, meaning you can't equal -3, and this one is open. If you have only open circles at a number, no closed circles, that means you can't equal -3 at all. So -3 is not represented in our graph. So that means if your graph looked like this, it would be -infinity to this -3, and then it continues from -3 to infinity. However, because it was closed, you can include -3. It's included right here. So every single number is represented. So this is what we have.
We can also just define it to be a constant and negative.
Okay, now let's do the range. Range is the bottom. So we have -infinity. And where's the very top of this graph? 7, do we go past 7? No. And we don't include it either because that's an open circle at 7. That's it. That is your domain and your range. Let's try another one together. Okay, so I'm going to plug in the number they gave me, -1. Let's plug that in. So I make a table. If I plug in -1 for x, let's see what my y is. -3 times -1 is 3. -7 is, so I got -4. Everyone plot that point. -1, -4 is right here. I did an open circle. Okay, what's my slope? Looking at the original problem, this is my slope, -3/1. So I'm gonna go, I wanna be less than 1, so I need to be on this side. I need to be on this side of the graph, okay? Because we wanna be less than 1, less than -1. So I'm gonna go this way. Up 3 to the left 1, up 3 to the left 1. So this is my line. Yes. So this is less than, all these points, this is the point -3. This is the x value -4. All of these x values are less than -1. We went to the left because we want to be less than. This point is -2. The x value is -2. So all these x values are less than -1. Do you guys see that? Okay, because the domain says x has to be less than -1. And all these x values are less than -1. Okay, let's do the next line. The next line, this is just the function. Think of this as y equals -5. Go to -5 on the y-axis and draw a line. 1, 2, 3, 4, 5. So this is the line, y equals -5. However, we just want it for numbers greater than or equal to -1. So I'm only going to draw this line from -1 onward to the right. That's that line. Okay. This is the point -1, 0. This is the point 0, 0. This is the point 1, 0. And it just goes on forever. This point is probably 1, 2, 3, 4, 5, 6, 7. 7, and I don't know what number that is. Okay, but do you guys see all the x values that are being represented in the graph? You have -5, -4, -3, -2, -1, 0. Do you see? What do you think the domain is going to be? It's represented everywhere. Just because you have an open circle here, it's okay because this one is closed at -1. So -1 is on the graph. It's being represented. Yes.
What is the D in R?
D stands for domain, R stands for range.
Oh,
Okay, now let's do the range. Range is bottom to top. So we have to think about what y values are being represented on this graph. Okay, now guys, we're thinking about the y values. So before I was writing the x values, now let's think about the y values. What's the y value down here? -5, okay, so that's -5. All of these are -5. What's the y value here? Are there any points between -5 and -4? No, okay, so guys, look. So far it's -5, just -5. I'm gonna put a bracket around it. And the next y value was a -4. And it's an open circle, so that'll be a parenthesis. And look, there's points all on this line. There's points all on this line. So that just goes -4 up to infinity. This line goes through all the y values. Okay, let's try another one. I'm going to let you guys do this one. I'm going to do this one because there's 3 of them this time. I don't want you to get lost. Okay, let's try number 6. I'm going to do the first one. guys, think of this as just the line y equals -1. So go down to -1, and it starts at -5. So 1, 2, 3, 4, 5. So right here. Uh-oh. Okay, so the line -1 starting at -5. 1, 2, 3, 4, 5, right here. So this is the line that goes through the y value -1, and it has all the x values that are less than or equal to -5. This is the first one. Now let's do the next one. Again, guys, just plug in the number. We have -5. Let's plug that into here. So you have minus, and then you have a -5 that you're plugging in. What do we get? 2. So if I make a table, I plugged in -5, got out 2. Let's plot that point. It'll be an open circle. Okay, if you want to, we can plug in the next number. The next number they gave us was a 1. Let's plug in a 1 this time. So in my table, I'll put a -1 in. What will this become? -2. So plot that point. -1. Oh, sorry, it was a +1. Thank you. Oops, this is a +1. So let's see what we get. Okay, so it's a +1. So let's put a +1 here. So this is -1 minus 3 is -4. Okay, there we go. So plot that point. 1, -4 is right here. So basically, it's going to form a line. Look at the original problem. What's my slope? -1, so just go down 1 over 1, down 1 over 1. And it's going to form a line like that.
Can you explain how you got the slope again?
Yep, this is how you get the slope. You can just imagine a 1 right there. This is your slope. This number represents your y-intercept. That's why right here you have a point on -3. And your slope is down 1 over 1, down 1 over 1. Okay, let's do the last one. I'll do the last one in blue. Okay, so this is the line y equals 6. So go up to 6 on the y-axis. 1, 2, 3, 4, 5, 6. This is the line that goes through 6. But remember, we only want the x values that are greater than or equal to 1. So I'm going to shorten this line. It's going to be from 1 to infinity. So 1, 2, 3, 4, 5, 6, right here. It'll be a closed circle, and it goes this way. And this is the y value 6. So that's the line y equals 6, but we only want it when it's equal to 1 or bigger than 1. All right, so that is what our graph looks like. Okay, so I have an arrow here that's -infinity. Let's follow it. I have a closed circle right here, so we're okay. It picks up after the closed circle. This is an open circle, but it's okay because I have a closed circle on the same line. And then it keeps going. So guys, this will be -infinity to infinity. Okay, now let's do the range. We start at the very bottom for the range. So let me use a highlighter. I start down here. Where is that? -4. Can I include -4? It's an open circle. So what do I write? Parenthesis. Parenthesis if it's open circle. Okay, follow my line, guys. It goes from -4 and it goes up to where? To 2. That's my next number. Do we include the 2? No. Because it's an open circle, so it's a parenthesis. Okay, now some of you guys might be wondering, well, what about this graph right here? Well, that's already included. That y value is -1, which is already inside of this interval. It's already taken care of. -1 is between -4 and 2, so it's already taken care of. Okay, then up here, what's the y value for all of these points? 6, so just a 6. And 6. We can put 6 in brackets because it's a closed circle. We can include 6. All right, so that's your domain and range. I'm going to let you guys finish this page to practice.